All right, this is the side angle side postulate for congruent triangles. It says that if two sides and the included angle are congruent to two sides and the included angle of another triangle, then those two triangles are congruent. So like we talked about before, we know two triangles are congruent if all of their sides are congruent and all of their angles are congruent. But that would be a lot of work to know that every single time. So we have some theorems that help us to prove that two triangles are congruent without knowing every single piece of that information, and this is one of them, side, angle, side. It says, and if we just look at this one triangle at a time, that if you have two sides from a triangle congruent to two sides from another triangle, and that angle that's between the sides you're talking about is congruent, then that is enough to prove that the two triangles are congruent. One thing that's good to do every time you're looking for, oh, how do I know these are congruent, is to look at your congruent markings, where the sides are located, where the angle is located. Notice that angle is between the two congruent sides. Thus, the SAS, the order of those letters is very important. The angle, A, is between the two sides, just like in the figure. Here, the angle is between the two sides. That does make a difference. Okay, let's take a look at this example. So one thing you'll need when you're working with side angle side is to be able to identify an included angle. So let's go through a few and see if we can determine where the included angle is and just talk about how that works. Okay, so here's the first one. Given lengths AB and BC, which angle is the included angle? So here, where's AB? That's the line from A to B. And BC, the line from B to C. Where is the included angle? Where here is our two sides. We want the angle that's included between them, which if you look at it, it's going to be the angle that they create. And one kind of a shortcut to finding included angle is notice they both share the letter B. That means that's where those two sides come together, and that will be their included angle. Okay, so for this instance, AB and BC, their included angle is the angle ABC. Now notice my B is in the middle of my name because that's where my angle is located. Okay, go ahead and clear this out and we'll take a look at the next one. Okay, on the next one we are looking for the included angle for AB and AC. So again, we go on the picture. Where's AB? Right there. Where's AC? Right here from A to C. What angle is created by them? That is their included angle, and it's this angle right here at A. Again, you could have used the shortcut AB and AC share the letter A in their name, which means they come together at that letter. So angle A would be our included angle. If I give its full name, angle BAC. Again, notice A is in the middle of the name because that's where my angle is located, is at A. Its vertex is located at A. Okay, let me clear again. Let's take a look at the next one, identifying an included angle. The lengths BC and AC. So BC is here, BC, AC. The included angle is the angle that's between them, the angle where they come together. So it would be right here at angle C, and we could call it angle ACB. Notice C is in the middle because that's where my angle is located. Again, you could use the shortcut C is shared between the names, so it would be located at C. The included angle would be located at C. And let me clear one more time for this last question. For triangle ABC, what type of angle is angle DCB? Well, let me look. Where is that angle? DCB. What type of angle is this angle here for the triangle? Well, its angle type, notice how it's created. We have our triangle ABC, and that angle is created by extending one side, and notice the angle's on the outside or the exterior of the triangle. And in the past lessons we talked about the exterior angle theorem. and how it's equal to the remote interiors added together. It is an exterior angle for that triangle. So it's kind of pulling in some old stuff on this last question, but these first three were spotting included angles. Hey, given the information on this diagram, what can we conclude? Well, we have two triangles. So far we've studied properties for determining whether they're congruent. We had SSS, told us the two triangles would be congruent, and we just talked about SAS. Do we have either of those? Well, looking at the markings on the triangle, this triangle only has two sides marked, and I know nothing about the third side. So I definitely can't use SSS. But notice here I have two sides here that are congruent to two sides here. So as long as I also know the angle between those sides is congruent, I can say that the two triangles are congruent. That can be my conclusion. So here's one side, here's the other congruent side. Notice here's one side, the other congruent side between the two triangles, and yes, the angle I know is congruent is the included angle, the angle between those sides. So what can I conclude? I can conclude that triangle ATC is congruent to triangle DBK. And how do I know? I know that by the SAS, side angle side.